One of the differences between actually blood pressure in afferent arteriole and other parts of other organs is that mean blood pressure in our capillaries in other organs is 17 millimeter of mercury. But pressure here is 60 millimeter of mercury. With this pressure, actually blood flows inside the glomerular capillaries. Right? Actually, this pressure is in favor of filtration because pressure is high. Filtration by which transport mechanism? What do you think? Simple diffusion, osmosis, facilitated diffusion, primary active transport, secondary, which one? Simple plus osmosis, okay? Osmosis is simple diffusion of water. Okay. As a result of this high blood pressure, we have filtration here. Filtration by simple diffusion. But it means there is no neutral energy as ATP. Was it clear? Was it clear?
Yes.
No, okay. If you have any question, don't hesitate to ask. Okay. What's the role of efferent arterioles? Actually, efferent arteriole decreases blood pressure in peritubular capillary. In a way that blood pressure in peritubular capillary reaches 13 millimeter of mercury. This is the main function of efferent arteriole. Efferent arteriole decreases blood pressure in peritubular capillary. For what? Actually, this low pressure is suitable for reabsorption. Got it? Low pressure allows substances to come inside the capillaries. Got it? It is suitable for reabsorption. And who decreases blood pressure in peritubular capillary? Efferent arteriole. Got it? Reabsorption by which mechanism? Here you can see simple diffusion by different mechanism. Simple diffusion, osmosis, primary active transport, secondary active transport, facilitated diffusion, got it? All transport mechanisms are involved here. Okay. After peritubular capillary, actually we have arcuate vein. Arcuate vein. And after that, interlobular vein. Interlobar vein. Renal vein. As you know, renal vein leaves the kidney through hymen. Got it?
Yes.
Very good. You want to take a picture?
What about the assignment artery? Assignment artery. Yeah, we know artery divided into assignment and assignment give us interlobar. So interlobar give us interlobular.
Actually, in different sciences, okay, the classification is a bit different. Okay, this actually branches of this. For example, in I don't make a mistake in anatomy, we say segmental artery.
Yes.
Okay.
Yes.
In physiology, we say in this way, but the branches are a bit, the naming, okay, is a bit different. Okay, it is the physiology of Guyton, based on the Guyton physiology. Okay. I think here, for example, you can segment the arteries. Each kidney contains about 1 million nephrons. Totally, how many nephrons do we have? 2 million. So any value, each value we will talk about is for 2 million nephrons and 2 kidneys. Got it? In an adult. Okay. Something else regarding this slide is that after birth there is we have no regeneration of nephrons. The kidneys cannot regenerate nephrons. Okay? And after the age 40 years, every year 1% of functioning nephrons actually are lost. In a way that in a person who is at age 80 years, a person in this age has 40% fewer functioning nephrons, but it is not life-threatening. Why? Because remaining nephrons do the function of the kidneys. Got it? Very good. Regarding the different parts of a nephron. A nephron is composed of glomerulus. Glomerulus. What is glomerulus? Glomerulus is Bowman's capsule plus glomerular capillary. When you say glomerulus, our name is Bowman's capsule plus glomerular capillary. Got it? As you can see, all the time, glomerulus is in the cortex. Above this line is cortex, below is medulla. Okay, as you can see, Bowman's capsule is in cortex. After glomerulus, we have proximal tubule. As you can see, proximal tubule or PT stands for proximal tubule, actually lie in the cortex too. After proximal tubule, as you can see, actually nephron penetrates into the medulla, and it is loop of Henle. Loop of Henle. Loop of Henle has 3 limbs, 3 functional limbs. One is descending limb. Descending limb. This part is thin ascending limb. And this part is called thick ascending limb. Don't you have any problem with the color? No? Thick ascending limb. As you can see, loop of Henle is in medulla. Okay? In medulla. After loop of Henle, distal tubule starts. Distal tubule. Distal tubule has 2 different segments. The first part is called early distal tubule. DT stands for distal tubule. Okay, it is in the cortex too. Early distal tubule, late distal tubule. Don't forget, the first part of early distal tubule is called macula densa. The first part of early distal tubule is called macula densa. Don't forget it. As you can see, macula densa is here. Lies between afferent and efferent arterioles. Don't forget it, okay? We need it for TGF, tubular glomerular feedback minute, macula densa and TGF. Got it? No question? Give a feedback to this, okay? At least nod your head. Don't you have any problem? No, just staring at me. If you have any question, don't hesitate to ask, okay? After distal tubule here, we have connecting tubule. Connecting tubule, as you can see by connecting tubule, nephrons join each other. And after that, we have cortical collecting tubule. Connecting tubule is in the cortex too. Cortical collecting dot is in the cortex, tubule, sorry, is in the cortex. And after that, we have medullary collecting tubule and medullary collecting dot, which leaves the renal pyramid through the tip of pyramids. Got it? Thank you for your reaction. No question? The deeper reaction, okay? Pay attention to the two types of nephrons. Cortical nephron or superficial nephrons, juxta, medullary nephrons. Pay attention please to the shape of nephrons, cortical and juxtamedullary. I'm going to talk about the differences. Okay? You have to look at the board. Okay? Pay attention to the shape of these two types of nephrons. As I told you, we have actually cortical or superficial nephrons, juxtal, medullary nephrons. The first difference is regarding the number, the percentage of these nephrons. Actually, 70 to 80% of nephrons are cortical. Okay? It means 20 to 30% is for juxtal medullary nephrons. The second difference is regarding Bowman's capsule. Bowman's capsules of these nephrons actually lie in the outer cortex. I mean outer part of cortex, okay? In the outer cortex. Bowman's capsule of juxtamedullary nephrons lie in the inner cortex. It is in cortex 2, but in the inner parts. Okay? The third one is regarding loop of Henle. Loop of Henle in this nephron is short, but it is long. It penetrates deeply into the medulla. Let me show the figures. Cortical nephron. Bowman's capsule is in the outer cortex. Bowman's capsule is in the inner cortex. Okay? Loop of Henle is short. Loop of Henle is long. It penetrates deeply. Okay? Until the tip of pyramids. Okay. Oh. The next one is regarding vascular structure. I mean peritubular capillary. Actually, peritubular capillary wrap around loop of Henle. Okay? It's not regular. It is completely irregular. Wrapped around loop of Henle. But here, peritubular capillaries actually lie in parallel to loop of Henle. They are called vasa recta. They are regular network, they form regular network of capillaries, but peritubular here is irregular. Got it? And the last one is regarding the function. These nephrons all the times are active. Okay? These nephrons are active, but their role is significant when there is water deficiency. What happens when we have water deficiency? Actually, in water deficiency, water must be excreted in urine or must be reabsorbed.
Reabsorption.
Must be reabsorbed. Okay? It means they play major role in urine concentration, in concentrating urine. Okay? They are active during water deficiency. Got it? Let me show you the peritubular capillary. As you can see, peritubular capillary forms an irregular network wrapped around loop of Henle. But here, they lie in parallel to loop of Henle. They are called vasa recta. Got it? No question? We're going to take a break or I can continue. Continue. Do you agree? Okay. Let me talk about the actual changes in the kidney during pregnancy, and after that you can take a break. Okay? During pregnancy, what happens during pregnancy? Actually, during pregnancy, we have functional and structural changes in the kidneys, and we have to distinguish these changes with the kidney diseases. Okay? What are these changes? Tell me please, in pregnancy, blood volume increases or decreases, or there is no change? What do you think? Increase. Blood volume increases. It means renal blood flow increases. Why? Because blood volume increases. Renal blood flow increases. Renal blood flow increases because blood volume increases. Renal plasma flow increases or decreases? Increases. Okay. GFR increases or decreases? Increases because renal blood flow increases. Okay. What happens when GFR increases? The waste material concentration of some waste materials such as BUN, blood, urea, nitrogen, and creatinine increases or decreases. When GFR is more, it means very good. Thank you for your reaction. When GFR increases, it means the plasma is filtered more and more. It means the concentration of waste material decreases. Very good, thank you. Okay, for this reason, concentration of waste material such as BUN and creatinine decreases. We have dilation of cholecyst and pelvis. It is called hydronephrosis. Okay, but this hydronephrosis, it is completely physiologic. Under other conditions, hydronephrosis is not physiology. It's not normal. Got it? We have dilatation of ureters. It is called hydro. I'm sorry. Hydroureters. It is called hydroureters. Okay. Okay, so in pregnancy we have hydroureter, hydronephrosis, we have increasing bladder capacity of urinary system increases, okay? Blood flow increases. We have decrease in renal vascular resistance. Decrease in resistance means vasoconstriction or vasodilation. Vasodilation. We have vasodilation of afferent and efferent arterioles. Got me?
Yes.
Thank you. Don't you have any question? Yes.
Can I repeat this slide?
This slide, okay. Actually, we have hydroureter. You know what hydroureter is? Dilation in ureters. Hydronephrosis, dilation in pelvis, for example. Okay. Increasing bladder capacity. Bladder capacity increases. Blood flow increases because blood volume increases. Renal plasma flow increases, as I told you. We have decrease in renal vascular resistance. It means we have vasodilation in efferent and afferent arteriole. May go something. Got it?
Yes.
No question? Okay. May I keep teaching? Can I talk about newborn physiology? Okay, thank you. Regarding newborn physiology, actually, nephrons are produced before 36 of gestational weeks. They have nephrogenesis. Okay. After this time and after birth, we have functional maturation. The function becomes mature. Okay. Okay. Combination of nephrogenesis, as I told you, in 34 to 36 of gestational weeks. There is no increase after the birth in human, the number of nephrons, okay? There is no nephrogenesis after birth. But in some species, such as rat and rabbit, nephrogenesis continues after birth. Nephrogenesis continues postnatally in those born before 36 weeks of gestation. Actually, it refers to preterm newborns, okay? No question? The kidney develops in a centrifugal fashion. What does it mean? I told you another name of cortical nephrons is superficial nephrons, okay? Actually, centrifugal fashion means first juxtamedullary nephrons develop, okay? And then cortical or superficial nephrons develop. But it is called developing in centrifugal fashion. Okay, take a 10-minute break or 15. 15. See you after 15 minutes. Buddy, please be in time. Okay, thank you.
Why is decrease? You said RVR decrease.
Resistance increases.
Yes.
Actually, resistance of all the cells decreases during the pregnancy because of having the better perfusion of organs. Okay, blood blood volume increases, suppose that there is vasoconstriction. We have increasing blood volume. Blood pressure increases more than normal, and it is dangerous.
Because the pressure decrease, the response is there is a relationship.